I believe that we are live. Uh, Welcome everybody. So we were doing this question. Sorry, the break took longer than 15 minutes. I suddenly some interview had appeared. I was trying. So we were doing this question, and we are still stuck, of course. So we found out the smallest index in the previous greatest index in the end. Like if it is empty, it's best for me to understand that it is empty. So -1 should work. And otherwise, I will just say that n be the index. So that if nothing exists on the right hand side, that should do the trick. So let's try and maybe see that what is going on. So for example, for 2, the answer is 4 wrong. But at least I'm sure that the right smaller index is 1 and the left smaller index is 0. Or should I start with, I think I should start with n. Yeah, and then here I should start with mm, -1. Maybe here also -1. But then that will probably give me an output error or some runtime error on this region. Like, I want a way for to specify that. Sorry, I want a way for us to specify that either the right index or small index does not exist. Okay, so let me just give an idea. But I'm thinking that so I think the it's working. Uh, yeah. So I'm maybe thinking that okay. So if this is 0, I mean index is 0, psi of 0 is 0. So previous smaller does not exist. Kind of. Wait. 1 and then n minus 1. I think I was wrong anyway. Where's that? Wait. Did I push n? Yeah. So I should put n minus 1 here. And this should not give a memory error at least. Because psi of 0, let's set it to -1. And index, I can put it as also this. So I need a way to kind of determine that what index I am comparing. So for example, for 2, I need to know that there is no previous element. And for the I have to know that the next element is 6. Like for 1, I know that there is no previous smaller element denoted by -1. And I know that for 1, 0, 1, 2, 3, 4. So wait, yeah, for 1, I know that the previous smaller does not exist. And the next smaller, I want it to be n. So 1, 2, 3, 4, 5, 6. So I want it to be 6. Like for n minus 2, like next smaller index. So NSI of n minus 1. For 3, it should be 6. For 2, it should be 6. For 6, the next smaller index is 4. 0, 1, 2, 3, 4. Is uh, 5, it should be 4 as well. Yeah. For 1, it should be 6. Yeah, exactly. 0, 1, 2, 3, 4, 5, 6. So 6 minus 1 is 7, but the distance is 1, 2, 3, 4, 5, 6. So I think the formula will be this minus 1, because I just need to find a way to kind of handle the boundary cases. So this is the only change that came to my mind. Like if the next smaller is not there, I can set it to I, can I? If the next smaller is not there, I should set it to the maximum I can. That will be optimal for me. And if something does not exist on my right hand side, then maybe this gets accepted. Really. Maybe I'm outputting a lot of stuff. Maybe if I remove these outputs, maybe this, then it may get accepted. Yeah, I'm doing a lot of outputs, by the way. Yeah, still outputs. Yeah, maybe now it will be accepted. Yeah. So the approach remains exactly the same. Basically, we find the next smaller index, the previous smaller index, and we push in some values. Like I'm thinking that PSI of 0 is undefined, but I need a comparison point. So I push to 0. And then from 1, I check that can it be 0 index? If it can be 0 index, I mean the index 0, then good, otherwise not good. Similarly for this, NSI of n minus 1 is n, like last thing, like the biggest I can have. Like for the boundary elements, what is the next one? The next one, because I can literally take this. Okay, so this was an edge case problem. One question was directly asked to me just a few seconds ago. That is not really directly related to this monotonic stack, but the question goes like, let's say I'm given an arrays of zeros and ones, given an array of 0 and 1, and I can flip maximum k. What is the maximum consecutive ones I can have? Like this is a recent question that has been asked to me. Like maximum consecutive ones after flipping maybe k number of zeros. But this is just maximum consecutive ones. But I want to after flipping zeros maybe. So maximum consecutive ones, and I have some k, yes. So let's try it on GAG practice. This is a medium question. So imagine this is basically a slightly going to problem, of course. Imagine that I start here. How far can I stretch? Like in a window, I am allowed to have k number of zeros, not more, not less. So I can set it int tail equal to, or let's say int L equal to 0, okay? And I can just loop over int R equal to 0, R is less than N, and R plus plus. So I will define this N equal to maybe V dot size. Of course, I have to change this guy to V, and of course, K is defined. Now I need a map, of course, map. Say maybe MP, it doesn't matter what name I got. So imagine that, so I'm starting at R, okay, so I'm keeping track of R, L to R. So first I need to increase my L maybe, like like while, or maybe count zeros. I don't need a map then. Do I? Hmm, let's try to do it with direct count equal to 0, like kind of keeping track of the count of zeros. And I can do if while this count is greater than k. So if v of L equal to 0, count minus minus, and L plus plus. And of course, L has to be less than L, right? K is, I believe, at least 1 or 0. So if count is greater than K, then it's an issue. Otherwise, I will just, if this is a result of window equal to 0, let's say window equal to max window R minus L plus 1. Of course, I have to try like get, so if count is less than K, less than equal to K, I mean less than K, of course, then I can just, if P of R equal to 0, count plus plus, and R is increasing anyways. So maybe in the end return this window. Let's see how it works. Okay, so expect your output is 11, K is 2. Like initially I started with L equal to 0, R equal to 0, or less than N. So count is definitely not greater than K. What is my value of K? 2. And L is still less than K. If V of L is 0, then count minus minus, other, and L plus plus anyways. Now, of course, if it is greater than K, we need this. Like I don't need because this will ensure that. Let's try to submit. Give some edge case now. Okay, so k is 0 in this case. If k is 0, so let me think that what is going on. For every L, okay, so V of L is 0, then count minus minus. Okay, I have to do this before because after this only I'm ensured that I think I'm allowed count is if count is greater than let's save this. So what if k is 1? Do I need this? V of L is 0, then what I can do that maybe for a given L, what is the maximum R there is? Kind of a two-pointer approach. Let's try. E1 equal to 0 and E2 equal to minus 1. Like a normal approach, while P2 is less than N. Okay, so P1 is less than N. Now I will try to eat up while and v of p2 plus 1. So either count is less than k, or v of p2 plus 1 equal to 1. That means I can take. So p2 plus plus, if v of p2 I mean v of p2 plus 1 equal to 0, then count plus plus. Result equals to max, comma, r minus l plus 1 and p2 minus. So this is kind of an approach. After this, I must do this while this game. Count is greater than k, then p1, if p1 is 0, then count minus minus, p1 plus plus. TLE. Anyways, p1 must be increased. Right? 13, 1, 2, 3, 4, 5, 6, 7. And p2 plus 1 is less than n. I think I do have a template regarding this. Let's see, 2 pointers. Yeah, so we kind of use this. Initially, we say int tail equal to -1, int head equal to 0. So while tail is less than n, if h plus 1 is less than n, and we count and we count is less than k, if p of h plus 1 equal to 0, then only count plus plus tail int n. And we do if it is equal to k. This is think about this. Four zero zero one two three four. Okay, I need conditions. If either count is less than k, or v of head plus one equal to one. 0, 1, 2, 3, 4. Is k equal to 2? That's the answer. Yeah, and the second case, 4, yeah. So, the only difference is that if I can take, then only I will take. Like, if head plus 1 is 1, then I can go in without any hesitation. But if it is 0, then I must ensure that my count is less than q. Okay, do we have any chat? I guess this works. Okay, how long is this training? Even though this is much shorter. So we have solved this question. So let's go through this template a little bit deeper. So this basically says that, okay, I have to insert this in my two pointer. A, B, C, D. Yeah. And this I must basically, I mean, maybe can take system. can take system. Oh, this is also to update your data structure. Data structure, same for this data structure. Okay, why is this tail? Yeah, yeah, this should work. So basically, if head plus 1 is less than n, and I can then head plus plus. If tail is greater than head, then tail plus plus, head less than n. Otherwise, just do tail plus plus. That is kind of the two-pointer template, basically dynamic sliding window. So we were solving these questions. We have solved a lot of questions like next greater, previous greater, and this is probably very easy. Have we solved this before? No. The next greater element of is the first greater element to the right of this. You given to 0 or blah blah blah, and the index j says that nums of 1 of j equal to nums of j, and determine the next greater element of j. So okay, so nums 1 is this bigger. Wait, next greater. The first greater element to the right of the x in the same n. You're given to okay, nums 1 is a subset of nums 2. Okay, so for 4, the next greater element does not exist. For 1, the next greater element is 3, and for 2, the next greater element does not exist. Okay, okay, is a subset. The index G such that okay, for example, 2, the next greater element of 2 is 3. Next greater element of 4 does not exist. This is an order n square solution will get accepted, so nothing special. Okay, so where were we? I think we were on this, yeah, monotonic stack. A lot of side was we went. And we have solved around 5 to 6 questions on monotonic stack. Let's get when the stack underflow occurs, empty, full screen this. Consider the following sequence of operations: push, push, pop, because 56 out, and then 19 out, and then 87 out, so 32. Monotonics, increasing stack, so it would be at the bottom. So find redundant brackets. Okay, basically a redundant bracket is such brackets such that There is no expression inside this, right? Okay, so have I solved this before? No, I don't think so. Some good companies. So let's try. T through S if x equal to my beloved, sorry, this is t dot push. Let's, this will cancel with this. If x equal to maybe plus, or x equal to minus, or x equal to division, or I'm keeping track of the signs as well. If x equal to closing bracket guy. Now, if st dot top open, then yes, so one. Otherwise, while top is not equal to st dot top, let's then return 0. Okay, so first is no, yes, okay. Second case, okay, this is a bracket. Good. This gets pushed. Okay. Like, for example, let's say, so first this gets pushed, then plus, then into that this good, the top is not open. So while is t dot pop, and again is t dot pop, because I need to pop the first bracket as well. Yeah. Okay. Solved. Okay. Valid parentheses. Well, this is a very standard stack question. Is there a way I can get back to my previous? Yeah. So if x is open, or x equal to, I don't know, this, or x equal to this, I just push. If x is this, or like and x is t dot top. Let's see that. Okay, let's say int p is equal to st dot top, or let's say char x, or let's say char t equal to, or if I say that, okay, so either x is closed and t is not equal to open, so it's invalid, right? T is not equal to open, or I have some other conditions. I mean, I can just do this. So for this pair, I want this, and for this pair, I want this. If this is not found, then we just return false. Otherwise, I can pop. Okay, wait. So okay, so unable to find the character literal operator. And this is the bracket for the if, right? This is the bracket for the for. I don't see an issue. Space, space, space. Okay, so not balanced saying the desired output is balanced. So maybe check. Let's put this into else block maybe. That really does not solve the issue, does it? Let me just, I don't know. No, no, no. Should be affecting these. Okay, let's see what's going on. So if it is open or this, I can just push. Otherwise, I will check the top and I will have three conditions. One is this, one is this. If any of them fail, then I will return false. Otherwise, I will pop. Of course, if st.empty, what if I don't have anything? Yeah, it works. Q basically FIFO data structure. Okay, so we have a lot of this. So pop, pop, pop. So 40 gone, 56 gone, 32 gone. So 99. So push and pop implemented an array constant, even though it depends. Q implement. Yeah, tasks pooling is what. Implement deck. I will use the standard deck then. What I can do here. Okay, how long is the stream running, by the way? I will keep it up to 1 hour. So maybe solve this question at last. We will continue from this. I've already reached rank 1, by the way, for this week. I don't know what it even means. Anyway, so take append tq and I will define a size. Int elements equal to 0 and then sz equal to 0. So once I have the end, so I will say that this for sz equal to 0, the push front, I will check if element number of elements is less than my size, then dq dot push front x and return true. Otherwise return false. Like if this is possible. Push rear means do the same thing but push back. Pop front means I will check if element equal to 0. I will have no element. By the way, after this, before returning, I should do le plus plus. By the way, otherwise I'm doomed. Top front, if L equal to 0, return minus 1. You don't get anything. Otherwise, return, or I should say, int p temp equals to pop front, right? So dq dot front and dq dot pop front, and I can just say that return temp. Same goes for the. Okay, before returning, I should do le minus minus. Okay, so pop rear again the same thing, but other than this, I will have back. Get front means if le equal to 0, return minus 1. else return front, right? tq dot front, q dot back, return le equal to 0, return le equal to n. It should work. Okay, I should say the le size is jet, right? For our case. Yeah, okay, directly passing. Okay, I'm an achiever, but not very good as you can see. 13% is nothing. But I will keep this 11 and I will keep this for WhatsApp as well, even though not now. Let's go next. Real life applications of stack and queue. Of course, backtracking is stack based, traffic management is queue based, browser history is stack based because order processing is queue, and this is definitely queue. Expression evaluation in fix postfix is stack, and customer service is queue. Introduction to recursion. So function calling each other, base case, recursive, self-work, believe, or the belief system, standard Fibonacci, everybody knows. Tower of Hanoi. This is a very standard problem of recursion. Of course, the expected time complexity is 2 to the power n. So 2 to the power is 16, up to 16 will work. Okay, so we want to return the way. So what we do is, so result maybe. We define some maybe function or recursive function. Maybe function, and of course the return type is void. If we take an index, let's call it recurrence, and let this be a function. Into what it will take? It will take source, int destination, and int auxiliary. And of course, the number of disks I must move. First, what we'll do, if n equal to 0, then nothing. Otherwise, all the same thing. So first I move source auxiliary, source to auxiliary in using destination as auxiliary and solve n minus 1. Then I do recurrent result dot pushback. So one disk I move from source to destination. So source to destination. Source, like from n minus 1 I move from source to auxiliary. Then I move disk 1 from source to destination. I think only one step, right? Yeah, source to destination. Then what you do is recurrence. I call from, I'm currently on my auxiliary to destination using source. Aux to destination using my source as the stuff. And we can just return this as, let's see, and okay, I must call this function by the way. Of course, I have to call this for n minus 1. And I have to call this select guy with, initially the source is 1, the destination is 3, and the auxiliary is 2, and the number of disks is n. So recurrence is not declared. Okay. Hmm. Function void int. Hmm. It takes an n by itself as well. Hmm. Okay, void, then I should not say int only, so maybe four ints. Right? I'm taking four integers. The type is an issue. Let's see, function was not declared. I don't need base C++. Come on. Basic. No, this is embarrassing. Okay, this, not this, it's destination. Yeah, I opened Docker by mistake. Close up, close. Okay, so 2x booster gained. Yes, then I can go a little bit longer. Okay, I will update this later. Come on, not Docker this time. Some heavy app. Family structure. So Akash is a member of a ninja club, like in coding ninjas. Okay, let's close this. And we have a first generation, second generation, third generation. Okay, given n and k, female, male. Okay, I have to know the male child first and a female child later. Whereas a female child gives birth to a female child first and then a male child later. Analyzes the pattern and what will be the kth child in the nth generation. Okay, okay, let's try to find a pattern. Yes. So let's think. So let's make the tree M, F. Initially, I'm starting with Akash, so M, F, M, and then M, M, F, F, M, F, M, M, F. Okay, so M maybe again, M, F, F, M, F, M, M, F. So first we have M, then M, F, then M, F, F, M, then M, F, F, M, F, M, M, F. What is the constraint? There should be some constraint, like what is the maximum value of n? Given that n and k will always be valid. Yeah, I understand. Are the constraints not defined? Okay, so int n and long k. So mathematically, I have to do because long int means that because for n there can be 2 to the power k, and 2 to the power n will be the value of like 2 to the power n plus 1, I guess. Every generation it So 2, 2. Second generation is female. Then 3, 4. It's a male. So let's try to divide this into odd and even. So MFFM, FM, MF, FM, MF, MF. So everything is starting with M. Second is always F. Third is always F. The fourth is always M. Fifth is always F. Is there a pattern then? Like if you look at it diagonally, that every guy here is an M, and every guy here is an F, and every guy again an F, and every guy again M, then F, then M, then M, then F, then again. So can I say that? So this is 1, 2, 3, 4, 5, 6, and this is 1. I mean, so let's define it like maybe parity on the number. So 1, then 1, 2, 1, 2, 3, 1, 2, 3, 4. So 3 plus 1 is odd, 1 plus 1 is even, 2 plus 1 is odd, okay. 3 plus 2 is odd. Sorry, 3 plus 1 is even. So 1 plus 1 is even, 2 plus 1 is odd. So like for odd, let's say for even hierarchy, like 2, 4, I can say that if it is odd, then it's male, otherwise it's female. And for first I will check if n is odd, then I have two cases. If n is odd, then I will check if n plus k is also odd. If n plus k is also odd, then the answer is male. Else written female. Otherwise, I can just flip the condition. Let's see if it works. Like I'm doing it diagonally or something. So male, male. Wait, so 2 and then 2. 2 plus 2 is even. For even guys, if n plus, let's not k check. Let's just to check for k. Okay, did I flip this by default? So maybe not this. Okay, not so good either. Let's try again. Let's try male, male, female, MF, FM. This is one, this is two, this is three, four, MF, FM, FM, MF. MF, FM, FM, MF. 1, 2, 3, 4, 5, 6. So everything starts with an M. Is it an easy question or a moderate or anything else? Easy, come on. Can you say that one is kind of like M it starts, then it will start from MF. The 3 will also start with MF only, and then only prepending will happen. Like, can I say that I can say that every ith generation is a prefix of the jth generation, and then it gets reversed. Like M started, so it gets repeated and then it reversed. MF, it's repeated, then it's reversed. Okay, a lot of patterns are emerging. So it's like M, then reversed, then MF, then FM reversed, kind of a palindrome. Like all of these are palindromes. No, not palindromes. Like the even ones are at least palindromes. No, the odd ones are palindromes. Yeah, the odd ones are definitely palindromes. Yeah, the odd ones are palindromes. The even ones are just bad. Let's try to see it as 0, 1, 0, 0, 1, 0, 1, 1, 0, 0, 1, 1, 0, 0, sorry, 1, 0, 0, 1. J and K are valid. Say K equal to 1, 2, 3. 3 by 2 is 1. 1, 2, 3. 1, 2, 3, 4, 5, 6. 7 by 2 is what? 3. 1, 2, 3, 4, 5, 6. 15 by 2 is 7. 3 by 2 is 1. 2 by 2 is 16 by 2 is 8. Flip. 8 by 2 is 4. Flip. 4 by 2 is 2. Flip. Let's do it like this. While k by 2 is not equal to 2 and k by 2 is not equal to 1. K divided by equal to if I landed on 1, if k 1 return male, else return and greater than 2. Like for example, 2 by 2 is 1. K by 2 is greater than 2. K by 2 is not greater than 2. Okay, K is 4. So K by 2 is 2. Okay, every time it will flip, by the way. Count, print count, do it like this. So let's say I give 14. 14 by 2 is 7. Flip to male. 7 by 2 is 3. Flip to female. 3 by 2 is 1. 1 is male. So 1, 2, 3 flips gives me male. Greater than 1. So if 3 flips gives me male, that means okay, let's check now. So 1. So 1 is by itself. To count is 0 then. That means okay, if it is 1, then again female. Wait, 5, 1, 5, 1, male, male. 4, 4. So imagine 4. So I'm at 4. 4 by 2 is 2. And 2 is a female. And 2 by 2, 1 is a male. How many flips? 2 flips. 2 flips. And I got a male. That means the answer was male. So I mean, if the can I say that if the number of male so then 0, let's say. Well, I think I should stop at 1. It is not critical. So 0 flips. If count equal to 0, count 0 flips means male. Four guy is also a male. Even number of flips means male. That is just and one. Okay, two. How many flips to one? One flip. So it must be male, female. Yeah. Print count zero. So k by 2 is not greater than if k is greater than 1. Female, male. Okay, some test cases best. Let's see. 7, 20. 20. Let's talk about 20. 20 by 2 is 10. 10 by 2 is 5. 5 by 2 is 2. 2 by 2 is 1. So 1, 2, 3, 4 flips. And 4 flips means female. But the guy 20 is a male. So M, F, F, M is 20. Okay, this is the wrong pattern. This breaks after 16. 15 by 2 is also 7. 14 by 2 is also 7. That is an issue, right? 15 by 2 is 7. And there is a flip. 14 by 2 is also 7. There is a flip. Hmm. There must be a simpler solution to this. Can I say that if n is the power of 2, the answer is even power of 2 and odd power of 2? Let's skip this question. And let's term of GP. And this is just binary exponentiation. Print series. Again, APGP. Subsets sum up to k. Again, basic recursion. Divide and conquer. I think we will continue next day on this family structure. I will maybe think about this problem in my sleep today. Okay, I believe good night. I hope you learned something today. I have a great day. Thank you very much. Like, share, subscribe.